Hello and welcome to Your Chemistry Tutor. I will be serving that role. I am Mr. S, and I've been teaching high school science, mostly chemistry, since 1992, and I thought I would make a series of videos to make that learning of chemistry easier for students, or maybe just a little help. So I've started these video series. This is episode 1. I'm calling it Stoichiometry. So let's get started. By the way, if you find this content helpful, you might like or subscribe and click the notification bell so that you can be notified when more videos come out. So we're learning about stoichiometry, and stoichiometry, to me, I see stoichiometry as a way to calculate quantities of chemicals in a chemical reaction. So here is a chemical equation that I wrote up. It doesn't mean anything because there is no element A. There is a B, but it's not just B. These are A and B, generic. So what this equation means is, see these coefficients here, 2, 3, and 2. Those relate numbers of particles. So there would be 2 particles of A. A would probably be atoms in this case. 3 particles of B2, which would most likely be molecules in this case. And you're going to make 2 particles of AB3, which are likely molecules, but could be formula units if A is a metal and B is a non-metal. This could be like if we were doing, I don't know, iron 3 chloride. No, iron 3 chloride. That's what this would be. So anyway, so 2 atoms, 3 molecules, 2 molecules or formula units are what we're making. What if we had 200 of A, and then we would need how many of B? Well, we would need 300 of B. If we had 2 million of A, then we would need 3 million of B. We would get 2 million AB3s. Is that a lot? It sounds like a lot, but as small as they are, it's really not a lot. In fact, for most of these chemical species, in order to have enough to even see, we need way more than millions. We need like 10 to the 20th, 10 to the 21st, 10 to the 22nd, 10 to the 23rd of these. And you know that a mole is 6.02 times 10 to the 23rd of anything. Could be atoms, could be molecules, could be pencil erasers. I don't know. It's like a dozen. It's a mole, but you already know that. So what if we don't have, so we would use 2 moles of A and 3 moles of B to get 2 moles of AB3. What if we only had 1 mole of A? What if we didn't have 3 moles of B2? What if we had 0.42 moles of A? Then how many B's and how many AB3s could we make? That's what stoichiometry is for. So let's take a look at an actual problem here. Wait a minute. Oh, before we get to the problem, mole ratios. Your teacher might, I've seen in a lot of books, textbooks, where they give you whole pages of let's calculate or let's write mole ratios for this equation, which is fine. You can do that. So what we're talking about is we're relating like A and B. What mole ratios could you make between A and B2? Well, we've got 2 moles of A and 3 moles of B2. For the purposes of this equation and for stoichiometry, if we're trying to figure out how much B we need if we have a certain amount of A, then if we use these 2s and 3s, that helps us, and that converts one into the other without changing the total, what we're doing in the reaction. So 2 moles of A over 3 moles of B, that's 1 mole ratio for these. 3 moles of B2 over 2 moles of A, That's the other one. Which one do we use? Just depends on the problem and where we are in the problem. Okay, but the point is, if they're kind of equal, then they put them in a fractional form and they both equal 1. And you can multiply by 1, you can divide by 1, and that's very easy. And it will change from one unit to the other without messing everything up, keeping everything in proportion, right? So what if we were looking at the A with AB3, okay? Well, then it would be 2 moles of A over 2 moles AB3. See, the 2's are from here and here. Just like the 2 and the 3, there's the 3, right? So 2 over 2, 2 over 2, they're both 1. 3B2 to 2 AB3. Well, do we put the B2 on top or do we put the AB3 on top? Just depends on which way you need it to be. These are not hard. You can do this. I went through it very quickly. If we multiply any of these, it's the same thing as multiplying by 1, which doesn't affect your math, and you don't even have to type that on your calculator, really. I mean, think about it. Do you need to hit times 1 on your calculator when you're doing a problem? I don't think so. Is there value in writing mole ratios? Yeah, probably. I don't spend a lot of time on it with my students. Maybe your teacher does. If you're not in my class, do what they want you to do, but it's not hard. You can do it. Is it crucial? If it makes a difference in your grade, I would say it's crucial. If it doesn't, then it's not. You are going to use them, though, in the stoichiometry process. So, crucial for doing stoichiometry, yes. You're not doing stoichiometry if you're not using the mole ratio. I can't say that emphatically enough. So, let's do an actual problem. So, when we're doing stoichiometry problems, you must have a balanced equation. I'm not going to give you any unbalanced equations today. I'm going to assume you already know how to balance equations, or you wouldn't be doing stoichiometry. If you don't know how to do balanced equation, wow, figure that out. Maybe I'll make a video on that at some point. B, you must have moles, right? And to get moles, you might need the molar mass. I'm hoping you already know how to do molar mass. My students learn molar mass on the first or second day of school, definitely in the first week. That's when we started, because it's so important. C, you must multiply by the appropriate mole ratio. Right there, see that? We've been talking about that for the last several minutes. And then you may be asked to convert back to grams or some other unit. So, most teachers are going to require you to show your work, including units on all numbers. I am like that too. And so here we go. Example. Given the equation, calculate the following. So here's the equation for the combustion of propane gas. How do we know it's combustion of a hydrocarbon? Because it's carbon dioxide and water are the products and the only products. So it's a combustion reaction. How many moles of H2O can form when 5 moles of C3H8 completely react? Well, we're looking for moles of H2O. How many moles of H2O? That's what I'm trying to find. And we got 5 moles of C3H8. And that's what I've been given. So the problem gives me 5 moles of C3H8 and asks me to find how many moles of H2O. So we always start with what we're given. Is it necessary to write all of this? Absolutely. Now, since we've already got moles, right? It says we must have moles. We've already got moles. So we're ready to do the must multiply by the appropriate mole ratio. Now, how do I know what the appropriate mole ratio is? Well, we're going to pretend, because it is, that there's a 1 there. So we're looking at this 4 and this 1, and the 1 goes with the C3H8. And notice I've got C3H8 in the top on the first term. Is this a term? I don't know. I'm not a math teacher. So I want moles of C3H8 in the denominator and moles of H2O in the numerator. And then I use the numbers from the balanced equation. So moles of H2O, 4. Moles of C3H8, 1. Now, my moles of C3H8 are canceled. If you don't put these units on, how will you know if you've got things in the right place? That's why I require units, because it's going to make you get the problem right more often than not. So now I'm done because it asks for moles, and the only unit I have left is moles of H2O, which is what I was looking for to begin with. So I'm just going to multiply 5.00 times 4 would be 20.0 moles H2O. Why not 20.00? Because that's wrong. Here's what I tell my student. Your teacher may be a stickler for significant figures, and if he or she is, wow, good for them. It doesn't have to be hard, though. Look, I started with 3. I did multiplication. I end with 3. What about these? Those are counting numbers. Those are absolutely known. Those have unlimited significant figures. You should know that. If you don't, now you do. We don't use things like that in calculating our sig figs. So we start with 3, we end with 3. Where that runs you into problems would be if it was such a thing that we ended up with a big old decimal, right? And if I went to round that to 3 sig figs, it is not those 3. These do not count, right? It would be the 1 and the 2 and the 5. Now, do we want those in front? They better be there. 125 is not the same as 0.0125, right? You could put it in scientific notation, which a teacher would love it if you would do that. If you put it in scientific notation, the zeros go away. If they go away, they're not significant. Your calculator does not do sig figs. So when you multiply 5.00 times 4, it's just going to say 20. And it needs to be 20.0. See, it doesn't do sig figs. Those zeros count. The ones at the beginning do not. That's for another lesson. That's another topic for another video. All right, part B. Oh, by the way, we were done with A. How many grams of CO2, that's what I'm finding, are produced from 22.4 grams of O2? Easy enough. We're going to start with our 22.4 grams of O2. We don't have moles. We have to convert to, right? We've got the balanced equation. We don't have moles yet. So we're going to have to convert to moles. So what are we converting to moles? Well, the only thing we have so far is just grams of O2. And how do we convert to moles if you've got grams? Well, you divide by the molar mass. And when I divide by the molar mass, I've got 1 mole of O2 over 32.00 grams of O2. And why did I do it that way? Because I want my grams of O2 to cancel, leaving moles of O2. See, I've converted to moles. Don't put this in your calculator yet. The next step is the mole ratio. And I like to say moles find over moles given. Well, what's my find? CO2. 3 moles CO2 over 5 moles O2. Now my moles of O2 are canceling. So I have converted from grams of O2 to moles of O2, and now to moles of CO2. If it asked for moles of CO2, I would be ready to use the calculator, but it doesn't ask for moles, it asks for grams. And how do I get from moles to grams? I need the molar mass. I'm going to multiply by the molar mass, which in this case is 44.01 grams CO2 over 1 mole CO2. And now it's time to turn on your oh wait, moles of CO2 have canceled. Now it's time to turn on your calculator. And you're going to, if it's on top, look, trick for doing these problems. Here's what I tell my students. The more buttons you push on the calculator, the more likely you are to push a incorrect button. It's just probability. The more you push, the more likely you are to push the wrong one. If a number is in the numerator, that's the top of the fraction, you multiply. If the number's in the denominator, that's the bottom, you divide. And I would not include these ones when I'm putting numbers in the calculator. I do not hit times 1 or divide by 1 because you don't need to. Multiplying by 1, dividing by 1 has no effect on the value. It's just more buttons to push that you don't need to. And then I would hit the equal sign only once at the very end. So type this into your calculator. 22.4 divided by 32.00. You don't even need the 00 times. Okay, so 22.4 divided by 32. They're zeros. They're significant, but your calculator doesn't mess with sig figs, right? 22.4 divided by 32 times 3 divided by 5 times 44.01, 44.01 equals. And when I do that in my calculator, I get 18.4842 grams of CO2. And if you put that, and you've got that stickler teacher who's going to count off for significant figures, then you're going to lose a point here. Because we started with 3 digits. This one had 4. This one had 4, but we always go with the least, right? I start with 3. I'm going to end with 3. 18 point. Now, I can't go 4 because after the 4 is an 8. 18.5 grams of CO2. There's my answer. Okay, let's do another one. How many grams of H2O will be produced when 43 grams reacts? So we want to know grams of H2O. That's what I'm trying to find. So we'll start with we got the balanced equation. Start with the given. One mole C3H8 over the molar mass of C3H8, which is 44.11. And then we're trying to find 4 moles H2O over 1 mole C3H8. Look, I'm going to cancel some stuff. Grams of C3H8, moles of C3H8. I've got moles of H2O. I'm looking for grams of H2O. So my next step, times 18.02 grams of H2O over 1 mole H2O. Moles of H2O are canceling. 43 divided by 44.11 times 4 times 18.02 equals. Now, before we solve this problem, I like to sometimes estimate an answer, so then if I do hit a button wrong on the calculator, I'm going to know it right away. Okay, so 43 over 44 is just less than 1. So just under 1 times 4 times 18, which is just less than 20, right? So it's going to be a number less than 20, or less than 4 times 20 would be less than 80. My answer should be less than 80. How much is it? Well, what I actually got when I punched it in the calculator, 70.26. 61528. which is a little bit less than 80. Again, I started with 3, there's 4, and there's 4, but I'm going to end with 3, so 70.3 grams H2O is my best answer. Next page. Feel free at any point to stop the video and work ahead on these problems and then check it with me. Okay, so if you want to do that, you're going to pause the video at any time. You can rewind it any time or go back, right? If I'm going too fast, slow me down. If I'm going too slow, speed me up. You have that technology. So if 25 grams of C3H8, I'm given that, completely reacts, what is the total mass of the product? Total mass of the products. So we got grams of CO2 plus grams of H2O. So we have 2 finds. So we're going to do this problem twice and then add the 2 answers together. So I'm going to start way over here. So here are all my steps. I'm going to cancel my grams of C3H8. I'm going to cancel my moles of C3H8. I'm going to cancel my moles of CO2. And I'm ready to do the math. And I end up with, for this one, 74.8 grams of CO2. I started with 3. I should end with 3. It was actually 74.82997053, and I rounded it to 74.8. Now we'll do the second one. 25 grams it's a 44. Let's cancel. Cancel. Oh, look, 25 times 4, there's 100. Times 18 would be 1,800 divided by 44. 1,800 divided by 44. I can't do that in my head. I got 40.9. And that question says the total. What is the total mass? So I need to add those 2 together. I'm going to get 115.7, I believe. There's my answer. Okay, one more, and we are finished. If we want to produce 44 grams of CO2, how many grams of H2O will be produced? Same thing. Given, fine. It doesn't matter where we are. Whatever you're given, whatever you're trying to find, it always works the same way. So we got 44 grams of CO2, 1 mole of CO2 over 44.01. Oh, that's convenient. Times 4 moles H2O over 3 moles CO2. All right, so grams of CO2 cancel, moles of CO2 cancel. Now I need to cancel my moles of H2O with molar mass. 18.02 grams H2O. Sorry, that's a little funky. Over 1 mole H2O. So 44 over 44 is about 1. So 4 over 3 over 18 goes into or 3 goes into 1860. It's going to be around 24. Should be around 24. Oh, it's right at 24. I got 24.0212023. If I round that to 3 sig figs, because we started with 3, everything else was bigger than 3. So 24.0 grams H2O. So that's it. We've done it. Hopefully this helps. And I will see you in the next video.